called out earlier that the point of object-oriented programming is to help define a real-world concept in a way that the computer understands. Defining a real-world concept in code can be tricky, so let's look at how we might go about representing a concept in Python code. We'll take it step by step and keep it simple. Let's take our Apple example from earlier. We could use this code to define a basic Apple class. Class Apple pass. Sure, it doesn't look like much, but with these two lines we've defined our first class. Let's check out the syntax. In Python, we use the class reserved keyword to tell the computer that we're starting a new class. We follow this with the name of the class and a colon. The Python style guidelines recommend that class names should start with a capital letter, so we'll be using that convention. In this case, our class is called Apple. Class definitions follow the same pattern of other blocks we've seen before, like functions, loops, or conditional branches. After the line with the class definition comes the body of the class, which is indented to the right. In this case, we haven't added anything to the body yet, so we use the pass keyword to show that the body's empty. We can also use the same keyword as a placeholder in any empty Python block. So, how might we expand our definition of the Apple class? Well, it would probably have the same attributes that represent the information we want to associate with an apple, like color and flavor. We can add that information like this. Class Apple, color, we'll set that to an empty string, and same with flavor, we'll set that to an empty string for now. So, here we're defining two attributes, color and flavor. We define them as strings because that's what we expect these attributes to be. At the moment, they're empty strings since we don't know what values these attributes will have. See how we don't need the pass keyword anymore now that we've got an actual body for the class? Alright, now that we've got an Apple class and some attributes, let's see our apple in action. Here, we're creating a new instance of our Apple class and assigning it to a variable called Jonagold. Check out the syntax. To create a new instance of any class, we call the name of the class as if it were a function. Now that we've got our shiny new Apple object, let's set the values of the attributes. Alright, we've just set the color and the flavor as string values. To check that it worked, let's try retrieving them both and printing them to the screen. Print jonagold.color, print jonagold.flavor. The syntax used to access the attributes is called dot notation because of the dot used in the expression. Dot notation lets you access any of the abilities that the object might have, called methods, or information that it might store, called attributes, like flavor. The attributes and methods of some objects can be other objects and can have attributes and methods of their own. For example, we could use the upper method to turn the string of the color attribute to uppercase. So print jonagold.color.upper. So far, we've created one instance of the Apple class and set its attributes and checked that they are now correctly set. Now, we could create a new instance of the Apple class with different attributes. Golden equals Apple. Golden.color, we'll set that to yellow. And golden.flavor equals soft. Both Golden and Jonagold are instances of the Apple class. They have the same attributes, color and flavor, but those attributes have different values. Congrats! You've learned how to create your own classes. Let's check that we've got all this down with a quick quiz. After that, we're going to learn how to define new methods for a class.